Alright, we're going to do a flip classroom notes for 5.3, which is perpendicular angle bisectors. I'm hoping the first two vocabulary words are review, perpendicular lines. Please write that down. You can paraphrase, but we should have lines that intersect at exactly 90 degrees. Therefore, there are lines that form 4 right angles. And I just drew an example of that. And I also put that box to make sure you know, and you have to see that to show perpendicular. Bisect basically means to divide in half, cut into two congruent parts. So our first review of a term for our first special segment is perpendicular bisector. So a perpendicular bisector is a line segment or ray that passes through the midpoint. So in this first blank we're going to put midpoint. And I abbreviate it, sorry, of a side of a triangle, okay, because these are the ones we're going to look at up in a triangle, and it is perpendicular to that side. So the key things, I know I highlighted the key information, but we're just going to kind of paraphrase this, make sure you understand what you must know. A perpendicular bisector has to pass through the midpoint of a side and is perpendicular to that side. Okay, and so we're going to use this triangle over here to the right to kind of just show an example of that. We're going to guesstimate. And we're going to use the side BO. And so basically, I think the midpoint would be kind of right here. And so we're going to draw a perpendicular segment. I'm going to use my ruler, and I can just line up my little markings, my tenths of centimeters or inches, and draw a perpendicular bisector. Now for it to show that it's a perpendicular bisector, we're going to have to add the box, and I might need to zoom in a little bit. Oops, went the wrong way, sorry. We're going to need to see if it's going to focus. Come on, please autofocus. We're going to add the box, and we are going to add, sorry about this, I don't understand why it's not focusing. There we go. We're going to add tick marks. Okay, so understand that it doesn't have to go through the vertex, but this is just an example of a perpendicular bisector. Now we're going to do some constructions on this next one to understand the theorem. And we're going to need a compass. You can use the safety compass or traditional compass. And I'm just going to use this traditional compass for this first example. Now, to construct a perpendicular bisector, we got to put our edge of our compass on the end points, okay? And we don't want to line it up on the midpoint. We want it to go a little bit past the midpoint. So I'm going to go a little bit closer to D. So what I'm going to do is I'm going to line up my compass, and I'm going to make an arc above, and I'm going to make an arc below, like such, my my segment. And I'm going to keep the same distance. I'm not going to change anything on my compass. Make another arc so it intersects my original arc above, and make an arc below. Okay, oops, had a little error there, but we should find those intersection of those arcs. I'm going to put a point to show that intersection. And basically I'm now just going to draw a line through my two intersection points, and that will be my perpendicular bisector. Let me line this up. Okay, and so to show that, I'm going to put a box to show that it's perpendicular. I'm also going to put a point of intersection on my segment CD. I'm going to go ahead and label that point B. And then I'm going to put tick marks between CB, and BD, so I can see it's a perpendicular bisector. Now, there's a special property or theorem that goes with a perpendicular bisector. And our theorem over here points on a perpendicular bisector. Any point on a perpendicular bisector of a segment is, in this word we use, equal distance. It is equal distance from the endpoints of the segment. So, equal distance from the endpoints of the segment. Now, our endpoints of our segment are C and D. Go back to where we are. Any point on our bisector. So just so we understand, if you need to, the line that I just drew right here, that I'm highlighting, that's my bisector, okay? I'm going to pick a point on the bisector. Anywhere on the bisector. Not the midpoint, but on the bisector. I'm going to put this point right here. And let's just label this point T. Okay? Now, the property or the bisector theorem states that any point on that bisector, my green line, is equal distance to the endpoints. So I'm going to now draw a segment from T. Oops, I'm going to do that with my pencil. From T to my endpoint C. Okay? Just like that. And I'm going to do that on both sides. So I'm going to do that from T to D. Make sure this is lined up correctly. Now, patty paper trace. I gave you some sheets of patty paper so we can trace to see the relationship. So, now, I'm going to prove or show that the theorem says that any point on this perpendicular bisector is equal distance. So what I'm going to do is I'm going to take my patty paper. I'm going to trace CT like such. And now I'm just going to rotate it, line it up with DT, and it fits perfectly. So I'm proving that those are equal distance. So now I'm going to put 2 tick marks to show that those two segments are the same. Now I'm just going to make sure. We're going to just verify. Remember, any point on the perpendicular bisector. So let's pick a point below. So we have a point here. We're going to make that point, let's make it S. Again, we're going to create the segment, the distance from this point to the endpoint, C. And then we're going to do also to D. And I can use my patty paper to trace it and verify and make sure. So I'm just going to find another spot on my patty paper, trace my segment, line it up over here, and it fits perfectly. Okay, so that's showing the patty paper relationship. Now we're going to actually do a patty paper perpendicular bisector. So hit the fast forward button so we can construct that together. Thanks.